All right, everyone, please take a look at the top here where it is saying that we are going to connect place value strategies to an algorithm. We've used that word algorithm quite a bit in our studies of math. We're going to be revisiting it in a lot more detail in the next couple of days. And we're also going to be refreshing our brains about the inverse properties related to addition and subtraction. So, up at the top, it is saying, what is the difference, and use place value to help you subtract. You will notice that this particular expression is already written in the vertical form. It's already lining it up. All right, that is very helpful. That is very, very helpful. So, in expanding this to subtract, using what we know about place value, we're going to take this 385 and we're going to expand it. That's our first step. That's our first step. So let's do that. So 385 is equal to 300 plus 80 plus 5. And then we're going to take 158 and we're going to expand that. So 158 equals 100 plus 50 plus 8. Now, when I do the expansion, and honestly, even before I do the expansion, I can already see that regrouping is going to be necessary. Why? Because this bottom number here, 158, is showing 8 ones, which is smaller than the 5 ones above it. We cannot take 8 away from 5. I do know I'm going to have to regroup or create more ones to make this subtraction possible. So when I do this, friends, I oftentimes do it in a different color ink because that helps my brain. So you at home, what could you do? Could you use a different color pencil perhaps? Definitely, definitely. That will help your brain. So I know, again, I can't take that 8 away from 5. I do need more ones. So this is what I'm going to do. I'm going to go next door. I'm going to go next door to the neighbor over here. I'm going to see what they got. I'm going to go, take some from the neighbor, regroup it, mix it up a little bit. So my neighbor has what I need. My neighbor has what I need. So I'm going to regroup by taking 10. I'm going to take that 110 and I'm going to move it next door. So instead of 5 ones, I now have 15. Again, notice what I'm doing here. I'm not changing that value of the 80, for example. I'm just regrouping, or I'm redistributing it so that I can make this subtraction possible, with the ultimate goal in our expansion and regrouping. All of these numbers, this expansion here at the top, these numbers in each of the respective places must be larger or equal to, at least, the number below it. So let's take a look and let's go by place and see if we just made that possible. So, is 15 larger than 8? Yes, it is. Fantastic. Let's move on. Is 70 larger than 50? Excellent. I can move on. Is 300 larger than 100? It is. Excellent. I'm all done. My regrouping is all done. Now I can find the difference. Now I can find it. And do not let these addition symbols trip you up. Remember, this is a subtraction problem. These addition symbols are showing expansion, not operation. I'm going to say that again. These addition symbols here in an expansion, that is simply showing the expansion of a number. That is not the operation of the problem. The operation is subtraction. We're looking for a difference. Now we can do that. Now I can say 15 minus 8, that's going to be 7. 70 minus 50 is going to be 20. 300 minus 100 is going to be 200. In order to find the difference, what am I going to do? I'm adding up this right here. And that is going to give me a difference of 227. Now, friends, can we connect this to an algorithm? For example, can we check our work? We definitely can. We can take this difference of 227. I can add it to the lower addend, which is here. And when I do that, that sum is equal, so that I know my math is correct. Remember, friends, addition is the inverse operation of subtraction. You may use addition to check your subtraction. All right? Again, friends, I am on page 66. We are specifically looking at the modeling. It is taking the problem from page 65 and showing you in another way, this time using our place value mats. Okay, so you will see 385 is here. They are regrouping it as we did on our expansion, noticing it's taking 8 tens and making it 7, but not changing the value of the 10 that's being regrouped, simply moving it next door to make the subtraction possible. So instead of 5 ones, we have 15. Instead of 8 tens, we have 7. Take a close look down here at the bottom with your regrouping. When you regroup, you want to make certain that what you create or expand equals the same as the original number. So let's say you're doing this regrouping, friends, and you say, oh, I can regroup with 3 hundreds, 7 tens, and 15 ones. If you decide to check your work, and I strongly encourage that you do that. If you decide to check your work on this regrouping, this new number, not number, but the values in the places that you are creating has to equal 385. Easy to check. You have 300 plus 70 is 370, plus 15 is 385. And yes, it is the same. It would be good to check before you proceed. Okay, so here is another way yet to model it. And now we are going back to, remember, grid paper, right? This grid paper here. This is like my chart paper that I use in the classroom. Sometimes friends find this more useful in keeping their numbers aligned. All right. So on here, you can see, again, the same problem, showing it regrouped. You have that same 385, showing you're reducing the 10 by 1, and you're increasing the 1 by 10. The value of this top number remains unchanged. You're just regrouping it. All right? Would it help to do things in different colors? You will notice throughout your textbook, things are done in different colors. Could that help you? Definitely. It could definitely help you. I love doing things in different colors. That does help my brain. All right? So, let's see. Okay, friends, so on page 67, these questions, you will notice, again, refers to the same problem we've been working on the 2 prior pages, the same numbers. But now it's asking you to connect all of that into your brain and put it into words. So you will notice there are less numbers and more words here, because it's asking you to explain. Remember, we're about the whys, to explain what it is that we have been doing. I want you to take a close look at question number 3 on the connected piece. Specifically, it is asking you, how would you complete the problem to find the difference? And this is when we are talking about putting the expression or the equation into a vertical form so that you can more clearly see the places and the place values. It is about regrouping with the ultimate goal of all of the top numbers in an expansion or a place value mat being larger than the bottom. And then you need to subtract each place. And on a math test, you would not only explain it, but you would show it. Does that make sense to everyone? So far, so good? Okay, awesome. All right, so we are here, question 7. First, we're going to read what? To see what the problem is about. Then we're going to close read it. Here we go. In 1 year, there are 180 days of school. That's actually not made up. There are 180 days of school. If there are 365 days in a year, on how many days is there no school? Check your answer by rounding. All right, so the important numbers for me, 180, super important. 365, super important. So I'm looking for the no school days. How many days are there no school? That's the actual question. all right? And this is what I'm going to do in a second color to help my brain. I'm not going to be done with just finding that difference. I also have to check my answer by rounding. This is a two-part question, friends. This is a two-part question. So there are a number of ways that we could approach this. There are a number of ways. If we were to use just the standard algorithm, for example, we could do that unless I specifically asked you to show me something different. So again, to help my brain, I know I am starting with 365 days in a calendar year. There are 180 days of school. I need to know how many days are in no school. All right? I know it's subtraction. So I could do the standard math. Okay. So 5 minus 0, of course, is 5. I cannot take 8 away from 6. I need to regroup. I need to go to the neighbor's house, see what they got. Do they have what I need? Yes, they do. 16 minus 8 is 8. 2 minus 1 is 1. There are 185 non-school days. Now, friends, there is the third grade math answer, and then there is like a fourth grade answer, right? So many of my students know as the year goes on, when I'm asking, for example, what's the fourth grade answer? They know to give me that answer in a complete sentence. They know to go a step further than the math. So the third grade answer, the third grade math answer, 185. The fourth grade answer, there are 185 non-school days each school year. Complete sentence. Does that make sense to everyone? All right, but we're not done. There's more. We're not done. Remember, answer questions being asked. That's what our close read is. That big purple box is going to refresh your brain. Uh-oh, not done. Not done. So it's asking you round to the nearest 100 to check. So could we have done that? Absolutely. How? I'm going to show you. Here we go. So if I take the original 365 days and I round that to the nearest 100, that's giving me about 400 days. And that little squiggly right there is what we call an approximation. It's about, notice the difference from an equal sign. It's not an equal sign. The little squiggly numbers, the little squiggly lines mean it's about. And then we take the 180 school days and we round that to the nearest 100, and that's about 200. So if I do the simple subtraction from my rounding, I'm going to get about 200. So when I'm going to check my answer using my rounding, I'm checking for what we call, this is a long word. This is a long word. reasonableness. I'm going to say that one again. Reasonableness. That's what I'm doing when I'm rounding. I am checking the reasonableness of my answer. So the actual math is showing 185. That's what I calculated. My rounding or my estimation is 200. Are these close? Yes, they're very close. Is my answer reasonable based on my rounding? It absolutely is. I'm going to call that good. Now, if these answers were hundreds off, would I want to go back and check my work? Oh yeah, absolutely. But here, we're in good shape. Okay? Awesome.